Hello, now I will tell you how to name an ionic compound, and we will start with four important sentences. The first one is that nonmetals gain electrons and get a negative charge. The second one is that we call negatively charged ions that anion. Anions means negatively charged particle. Third one is that metals always give electrons and get positively charged. Four is that they are called cations when they get positively charged. Positively charged particles. The second important thing is that the knowledge of periodic table. We can determine the charge of an atom by looking its place on the periodic table. As you see in this figure, that the 1A group is commonly plus 1 charged, except hydrogen. Hydrogen is mostly plus 1 charged, but sometimes if it combines with metals, it is minus 1 charged. Anyway, the 2A group is always plus 2 charged, and the third A group is always plus 3 charged. Then we go through the anions and nonmetals. As you see here, these groups, there are some semi-metals here, but for the nonmetals, they are negatively charged, and according to its group, we can find we can find its charge. For example, think about nitrogen here. It's in the 3, 4, 5th A group, 5A group, and to complete its octet, it needs to take 3 electrons, so it is minus 3. I can also explain it that way. For example, think about calcium. Its position in periodic table is 2A, and if it is metal or non-metal, it is metal. What this means? Metal means that it will be positively charged, and 2A group means that it is positive 2 charged, so calcium is, when it combines, it is plus 2 charged ions. And think about oxygen. Oxygen is in the 6A group in periodic table, and it is a non-metal, and because it's a non-metal, this means it will be negatively charged, and to find the number of charges, we need to subtract its number of group from 8, so oxygen is minus 2 charged here. Here are the charges of most common elements in their compounds. As you see, the phosphorus element here is minus 3. Why? Because it's in 5A group. It's a nonmetal. Because it's a nonmetal, it will be a minus. And after 5, 6, 7, 8, there are 3 levels, so it will be minus 3. And you see as xenon as 0 because it's a noble gas. Lithium is in 1A group and it's a metal. Because it's a metal, it's positively charged and the number of group is 1, so it is plus 1. Now we can go through the next step, and it is the rules for naming ions. It's easy for metals. When a metal lose electron, we can type here, when a metal electron loses electrons, it becomes ion and its name does not change. Here is the example. Think that this is the sodium element, and if it loses its electron, the name of this ion is again sodium. However, in nonmetals, the name change. Name change when a nonmetal turns into an ion. See here, this is fluorine. If it gains an electron, now its name will be fluoride. You see here, we subtracted ion and we added ite. Now let's predict the ion name of these nonmetals. We just add ite to the root of the element name. Here, what is the root of the element name? Here it is, sorry, it is chlor. Sorry again. Here it is nitre. Here it is ox, and here it is sulf. So we just add I, D, E, and they will turn into chloride, iron, nitrite, oxide, the famous one, and sulfide. Let's go on with more example. Talk about potassium. And what will be its ion name? It will be again potassium. Why? Because it's a metal and the name doesn't change. What about lithium? Testing if it is a metal or non-metal. Lithium is metal, so its name will not change. It will be again lithium. What about bromine? Is it metal or non-metal? If you don't know the periodic table very well, it will be difficult. If you know it, it will be very easy. Bromine will be bromide ion because it's a non-metal. There are also ions that form after elements have shared their electrons, and we call them polyatomic ions. Let's type here. Be aware that there are polyatomic ions. And the important thing is that each of them has a special name. So you can predict their name. So you need to memorize them. Here, the common polyatomic ions, you need to write down these names several times and memorize them all to be able to name ionic compounds. One of the most important parts for naming ionic compounds is the transition metals. What is important for them is that their charges may differ. For example, iron is a transition metal and its charge can be +2 and sometimes it is +3. And the second thing is that we need to write their charges using Roman numerals with their names, of course, not with the formula. For example, the name of this ion is iron 2. There is no ion that is called iron, and the name of this ion is iron 3. We are sure that they are always positively charged. Why? Because they are metals. Because they are metals. And here are the most common transition metals. As you see, chromium have two ions, and their name differs with Roman numerals, as you see here. For example, lead can be lead 2 and lead 4 according to its charge, and mercury, tin, and iron. Now we are ready to name an ionic compound, and there are two steps for it. It's really easy if you know the essential things. The first step is to write the name of metal ion, because there will be two ions, metal and non-metal. And the second step is simply to write the name of non-metal ion. Let's see how it works. What's the name of this compound? Don't think about the numbers for now. The name of the metal ion is the same as element name, calcium. And the name of the non-metal ion is bromide. This is it. Let's go further and name this ion. What's the name of this? It's simply name of the cation, sodium, and name of the anion, fluoride. Be careful, it's not fluorine, because now we are talking about the name of non-metal ion. You should be aware of this. Another example is lithium. I don't want to say what's the name of this. lithium sulfide. One more, it is potassium iodide. And if there is a polyatomic ion, we should simply use the name of the polyatomic ion in the compound. For example, which is the polyatomic ion? Here, show you that this is the polyatomic ion. And of course, you need to remember the name of it, not this one. It is sulfate, and the name is calcium sulfate. One more example, the polyatomic ion can be a cation too, as in here, NH4F, and the name of this is ammonium and fluoride. And one example with the transition metals, let's think about so here we see that the iron has +3 because of this 3. So the name of this is iron 3 oxide. For transition metals, in the next video I will explain them further. And this is all for now. So, and thank you for watching.